All right, we're going to look at logic part 4, which is actually going to use all the things that we've been doing with truth tables to help us determine if certain arguments are valid or not. So the first thing that we have here is a statement that a logical argument is a claim that a set of premises support a conclusion. A deductive argument is said to use a collection of general statements as its premises and then use them to propose a specific situation, which is the conclusion. So what's your first intuition for the validity of the following set of premises and conclusion, and why? All men are mortal. Socrates is a man, therefore Socrates is mortal. So what do you think? Do you think that the premises, which would be these two things, can help you to conclude that ending, that conclusion? Write down what you think, and then we're going to actually prove it in a minute, whether it's going to be valid or not. So let's see, let's rewrite the statement. All men are mortal as a conditional statement. So what that really means is that since it says all men, it means that if you are a man, then you have to be mortal. So we went from a statement that had that universal quantifier all, and we rewrote it into that conditional. Now, we could do that again for our statement, Socrates is a man. So if you are Socrates, then you are a man. And I noticed that I forgot to give the variable name. So let's say that if you are a man, so you are a man is what we're saying is P. You are mortal, we're saying is Q. Saying you are Socrates is a brand new statement, so we'll call that R. And you are a man goes back to P. So we have right now that P implies Q. And for our Socrates is mortal, we'll say R implies P. So for this next part, it wants us to string together these two forms and see if we end up basically with that conclusion that Socrates is mortal. And so you can see what we have. There's kind of a matchup with this premise and this conclusion. So knowing that R implies P, if we have P, then we know that that will imply Q. So we can write this together and really say that that means that R implies Q, where R was Socrates, if you are Socrates. So we're going to say that if you are Socrates, then, and then again that Q was that you are mortal. So it does come up to that conclusion. So if you thought that this was a valid statement here or premises with a conclusion, then you were right based off of using those two conditional forms and combining those together. So we say that a deductive argument is considered valid if, assuming all the premises are true, the conclusion logically follows from those premises. In other words, when all the premises are true, then the conclusion must be true. So if we know that R is true, then and P is true, then we know that P is true and Q is true. If all those are true statements, you can see that string working out. So then, as demonstrated in the example above, we're really getting this rule of transitivity. So if A implies B and B implies C, then we can go straight and say A implies C. And I wrote that right up above there. R implies Q is really what we're getting from all of that. All right, let's try it a couple more times. We have, actually one says, use the rule of transitivity and symbolic notation to determine whether this argument is valid. So it says, no snake is warm-blooded. So what that really says that if you are a snake, so let's say P, not if, that can't be a question. So it's saying that you are a snake, and if Q is you are warm-blooded, And let's get one more in there, looking further ahead. We talk about mammals. So let's say you are a mammal. Let's see what we have here. When we have the no, snake is warm-blooded, what that means is if you are a snake, then you are not warm-blooded. So using those P's and Q's together, that's what that statement says. For the next one, all mammals are warm-blooded. That means that if you are a mammal, so if you are, that implies you are warm-blooded. And so what we want to get out of this is to see if, in fact, snakes are not mammals. So we're going to assign these variables, which we got going on, and then it also gives us a hint reminding us about a conditional and its contrapositive. Those are equivalent to each other. So as soon as I see that kind of negation, this negation going on, we could either change to the second one, to its contrapositive, and then see a connection. So let's see how that works. So if I rewrite this to not Q implies not R, you can see that we have a string built up here, looking at these ones connected, because as soon as you have a conclusion and a premise that match, we can combine those together. So what that would mean then is that we would have P getting us not R. And that is that if you are a snake, you are not a mammal. So that looks like a valid statement that we had going on up here. We can also do this using a Venn diagram, or sometimes your book will call it an Euler diagram. And what that would look like is when we say that no snake is warm-blooded, we can have the set of all warm-blooded things. And so snakes would not live inside of that because it says no snake is warm-blooded. Now, we know that all mammals are warm-blooded from that second statement. So that means that all of the mammals would live inside here. And so then it follows that snakes are not mammals because there's no way for snakes to be inside of that. And so we would say that that was a valid argument. All right, for exercise 3, we have this next set of statements that says all professional wrestlers are actors. The Rock is an actor, therefore The Rock is a professional wrestler. So for the very first statement, we know that if you are a professional wrestler, that this implies, kind of mixing up my notation with English here, we'll say then you are an actor. And I'm going to call, let's see, you are a professional wrestler, let's call that P. You are an actor, let's call that Q. Now our next one says The Rock is an actor. So if you are The Rock, then you are an actor. And so if you are The Rock, that's a new statement. We'll call that R. And then you are an actor. We're going to call that Q. And so what our argument really is saying that if you have P implying Q and you have R implying Q, then Rock is a professional wrestler. That is, R implies P. So remember that we can use that transitivity only if we have a matching hypothesis and conclusion, and we don't have any of that. Only the conclusions are matching up. So it doesn't seem like there's a reason why that would logically follow. So right now it seems like it would be invalid. So let's take a look at this. It says to use that Venn diagram. So if we know that all professional wrestlers are actors, that means that inside the actor circle, we have all professional wrestlers. Now we have that The Rock is an actor, and so The Rock could live either inside the professional wrestling circle or the actor one. We're not quite sure. And because of that, that's letting us know that we have an invalid argument. Now remember, just because we have something that is invalid does not mean that the conclusion is false. I mean, The Rock is actually a professional wrestler. It's just that based off of the argument that was used to obtain that conclusion was what was invalid. Okay, so in logic, validity and truth do not have the same meaning. Validity refers to the process of reasoning. So you can see that the reasoning that was used here to obtain the conclusion just wasn't good. Okay, so let's look at number 5. We have, again, the same kind of situation, but we're looking at all doctors being men. So what that means is if you are a doctor, then you are a man. And we have that my mother is a doctor. So we could rewrite that. If you are my mother, then you are a doctor. So I'm going to label my statements just so I can see them in that symbolic logic. So you are a doctor, we'll call that P. You are a man, we'll call that Q. You are a mother, that's a new statement, R. You are a doctor is P. So what we have currently is that P implies Q and R implies P. And so we want to get to this statement, my mother is a man, which using our notation would say, if you are my mother, then you are a man. R implies Q. And you can actually see with that transitivity, because we have that hypothesis inclusion matching up, we could say from this that R implies Q, which is what we were just saying. So that would be a valid argument. Now, kind of going through what I had said before, that there is that difference between validity and truth. Saying an argument is valid doesn't mean the conclusion is true. As seen in exercise 5, if talking for myself, my mother is not a man, so that would not be a valid argument. So just because an argument is valid merely means that given those particular premises, the reasoning used to get the conclusion is logical. So if the premises of the valid argument are true, then the conclusion must also be true. However, if any of the premises of the valid argument are false, then the conclusion will also be false. Okay, so you can kind of see that going on. We could do that Venn diagram again for the situation. So all doctors are men. That means if we're thinking about men, we are sticking all doctors into that. And then we're saying that my mother is a doctor. That means that she would have to live inside here. And that forces her to be a man because that is inside that men's circle. So we can see through that Venn diagram that that is also valid. Okay, so let's go back to that original statement about no snake is warm-blooded, all mammals are warm-blooded, therefore snakes are not mammals. So we've done it by looking at the conditional statements and transitivity. Now we're going to look at using a truth table. So to use a truth table to prove an argument, what we want to say is that if we have these two premises being true, that means both of them being true. We're going to stick a little and between them. We want to see that that implies the conclusion. So that's going to be kind of our ending here. And if it does all the time, meaning we get true for everything in that statement, we have something called a tautology. And that would show that our argument is in fact valid. So we have those 3 different statements here. And so we're going to label them or give them truth values. Remember the very first column, I do half and half. Second one, I do half, half again. And again, this is just one pattern to make sure that you get all the possible combinations of these 3 statements. So the last one will alternate. Okay, and so what do we need to know? We need some negation. So we're going to get a not W. Not W just changes these, so it's going to alternate. And then we need a negation of M. So that's going to be false, false, and then true, true, following that pattern. Okay, and now we need some implications. So let's look at the first one, S implying not W. So remember that the conditional is only going to be false if we have that broken promise situation going on. So we're looking at S going with not W. So true implying F, there you go, there's your false. True implying true is okay. True implying false is not. True implying true is true. False to false is okay. And all the rest, because they start with a false, then they're going to be true statements. For the next one, we're going to look at M implying W. So we're looking at the M and the W. So true, true is true. True, false is false. False, true is true. True, true. Here's a false, true implying false. True and true. Now we want to combine these statements together to find out that truth value. So when we say and, remember that means both things have to be true. So right now, for the and of that, we're going to have a false, false, false. We have a true, true, false, true, true. And so we want to see if those are our premises, if those combined together really do imply that S implies not M. That is, the snake is not a mammal. So let's go back and make the conditional for that. That's what's going to live inside here. And so we're going to have our S, that's our very first column, with our not M column. So we have true to false, that's false. True to false, that's also false. True, true is true. True, true again. False, false. False, false. False, true. And false, true. So remember, conditionals, if they start with false premise, they're always true. If they start with true, you just need to make sure that it follows through with that promise. This a little neater here, that's a false. So we want to see if, oops, not that one. This and statement really does go to this one. So that's our last step, is that conditional. Does it imply this? And so we're going to look. False, false, that's true. False, false, that's true. False, true, that's okay. True, true is okay. The only time that it will be false is if you have true implying something false. So these are all true. And so we have this tautology, which means that we have a valid argument. Again, we already did it with the Venn diagram. Now we're just showing that it also can be proven with a truth table. Okay, so we have something kind of interesting down here to kind of play with that transitivity a little bit. So it wants us to create some conditional statements, and then we'll try and see using the rule of transitivity and a little bit of De Morgan's laws about some more going on with the situation than just initially stated. So using our logic skills, let's see what's happening. If Ty is invited to a party, then Juan won't be invited. So that means that Ty implies that Juan will not be there. Now, inviting William means that we have to invite Ty and Sam. So if William, we're going to say that implies Ty and Sam. We will invite Alma only if we invite Juan. That means if Alma's there, then it implies that Juan was invited because it's a necessary condition. We also have that if we don't invite Mario, then we'll have to invite William. So that means that not Mario would imply that William is there. Okay, so based off of those conditionals, well, let's write their contrapositives. So for this first one, the contrapositive, remember that flip-flops it and negates it. So we're going to have that Juan implies not T. For this next one, we're going to have negation of Ty and Sam implies negation of William. But again, De Morgan's laws would say that this would be not T or not S would imply not W. Because a reminder, De Morgan's law says, kind of like distributing, it flip-flops from a conditional to a disjunction and vice versa. So not T and S implies not T, or not S. And then we also have that for the disjunction that turns into the conditional. We've already proved that, so I'm not going to prove that here, but we can use those facts. Then we have A implies J. That would mean not J implies not A. And the last one, we'll have that not inviting William implies that Mario was invited. Okay, so we're going to kind of match up some of these to get a long string of implications. So it says one using the original conditionals and another using the contrapositives of each statement. So let's see what we can match up. So remember that if you have a conclusion, then we can, a conclusion and premise matching, then we could line those up. So let's start. What do we have? I see that we have a 1 here, and then we have 1 implying not T, and then I have that not T or not S, so as long as we have not T, would get us not W, and then not W gets us back to the M. So that what that's saying, if I start that we have A implying J, but we know that J implies not T, and then that's going to imply not W because of this statement here, and then not W implies M. So really this is telling us that if Alma is going, then we know that Mario is going. So that's kind of our big string, works us through that. So when it says who else we invited, if we invite Alma, we know for sure that Mario will be. And so then we have the kind of reverse of that. So kind of working our way backwards, that would look like not M implies W implies T implies not J implies not Alma. So who else will be invited if we don't invite Mario? Well, we know that if we don't invite Mario, then we would have William. And we know that if William comes, then we have Ty. And then if we know Ty comes, we know we won't have Juan, and we won't have Alma. So we know those William and Ty would be invited. And again, overall, we're saying that if not Mario, then not Alma is happening, which you can see is the contrapositive of that as well. So just kind of some fun using that transitive property of these conditionals to come up with other conclusions. So that's logic.